Okay, so the solution to down to the wire. Let's start by writing down our equation for our standing wave. Y is equal to 0.00200 sine pi x cos times 100 pi t. And so from this, we know that the amplitude is equal to 0.002 meters. We've got the k, the wave number, in front of the x here. So this here is k, so k is equal to pi, and we know that k is equal to 2 pi on lambda. So we can use this now to work out lambda. So lambda is equal to 2 pi on pi, so that's equal to 2. So 2 meters is our wavelength, and we know that omega is in front of the t. So omega is equal to 100 pi, which is equal to 2 pi f. So f is equal to 100 pi over 2 pi, and so that's equal to 50 hertz. Okay, so now we've written down what we know. Let's look at the question now. So part A says, how many loops does this pattern exhibit? And we're told in the question that our piece of wire, L, is equal to 3 meters. So for a standing wave, we see a pattern which looks like this. And each of these loops is half a wavelength. So we need to work out how many half wavelengths fit into 3 meters. So we've got lambda over 2 is equal to, we've worked out what lambda is, so this is just 2 meters over 2, so that's 1 meter. So that's length of a loop. So that tells us in 3 meters we would have 3 loops. Okay, so 3 is the answer to the first part. Part B then says, what is the fundamental frequency of vibration of the wire? Okay, so for the fundamental frequency, we just have the one loop. That will be the lowest frequency for which we'll get a standing wave pattern. So if we've got one loop, we know that lambda over 2 is equal to 3 meters. So that tells us that lambda is equal to 6 meters. So we've got lambda, and what we're asked to find is the frequency. So we can use V equals F lambda. If we do not change the tension and the mass per unit length of the wire, which we're not doing in this case, then we know that the velocity is going to remain the same. So we can call this F1 lambda 1 because this is the fundamental. So the subscript 1's good to use for the fundamental. And the velocity of the wave for the fundamental is going to be the same as when we had 3 loops, and 3 loops was the third harmonic, so that'll be F3 lambda 3. Both of these equal to the same velocity. And we know what these things are, and what we're trying to find is F1. So we can rearrange this. We've got F1 is equal to F3 lambda 3 over lambda 1. Now F3, we worked that out up here. It was 50 hertz. So that's 50 hertz. We worked out that lambda 3 up here, it was equal to 2 meters. And lambda 1, that's the wavelength of our fundamental frequency, is equal to 6. So we can now solve this, and we end up with, well, 50 over 3, which is 16.7 hertz. Okay, and now finally C, if the original frequency is held constant. Okay, so now the frequency again is F3, which is 50 hertz. And the tension in the wire is increased by a factor of 9. So the tension goes, is now, let's call this the new tension, is now equal to 9 times the old tension. How many loops are present in the new pattern? Okay, so we know that the old velocity is equal to the old tension over mu, the mass per unit length. Now the mass per unit length isn't changing because we're sticking to the same string. So the new speed is going to be equal to the new tension over mu, but the new tension is equal to 9 times the old tension, and it's under the square root sign. So the square root of 9 is 3. So this will be 3 times the square root of the old tension over the square root of mu. And this part is just equal to the old velocity. So this will be 3 times the old speed. So it's now going 3 times as fast as it was. And we know that v nu, this is one equation for the wave on the string. We also have that it's equal to f nu lambda nu. And so our new frequency, well, the frequency remains the same. It's still 50 hertz. So this will be 50 times lambda nu is equal to 3 times v old. But v old was equal to the, just because v equals f lambda again, we can use the old frequency, which was 50, and then the old wavelength we calculated up here was 2. So we're trying to find this. So we're equating this part here with this part here. And so we have lambda nu. This 50 will cancel, this 50 will equal 3 times 2. So that's going to be equal to 6 meters. Now, the question asked us how many loops, and a loop's equal to half a wavelength. So lambda nu on 2 is equal to 3 meters. And if the new wave, if this is the length of one loop, and that's equal to the length of the string. So now we see one loop.